So welcome to the video. Today we're going to take a look at how to do a Pearson correlation analysis on version 31 of SPSS. So we're going to use this analysis when we have two or more continuous variables and we want to know whether there's a correlation between those variables. So there could be a positive correlation, which would mean that as one variable goes up, so does the other variable, or there could be a negative correlation, which means as one goes up, the other one goes down. So for this example, we're going to use some data from this study mentioned on this website. The data come from people picking up marijuana prescriptions or something at a clinic, and it's to do with whether their cognitive abilities are related to their emotional or mental health. More specifically, we're looking at cognitive function and anxiety. So in this column here, higher scores represent higher levels of cognitive function, and in this column here, higher scores represent higher levels of anxiety. And we can see that we have some -9s in both of these columns, and the original creators of this data used -9 to represent missing cases. So we'll just take a look at how to ignore those, because if we don't tell SPSS to ignore those, it's going to treat those as real data in the analysis. So what we're going to do first though is just go to SPSS, then we'll go down to variable view, and then we're just going to give some names to these variables. So one of them was cognitive function, so we'll put that in this name column. Cognitive underscore function, so we have to use an underscore because we can't use a space. Then we'll go down to the next available cell and we'll say that this is anxiety. We'll then just use this measures column to specify that we have scale data. And as I mentioned before, we just need to tell SPSS that -9 represents missing data. So we go to this missing column here, and if we click on this cognitive function row and then on this box here, and then we'll go to discrete missing values, and then we'll put -9 into one of these boxes. Then we'll go to OK, and we can see that -9 now comes up there. And we can actually just copy and paste this. So if we go to this cell here and then we press Command or Control C, and then if we go down one and then if we go to Edit and then Paste, we can see that -9 also appears in this anxiety row. So now SPSS is going to treat any -9 values in those two columns which we have here. If we go to Data View, it's going to treat those as missing cases. So we're now ready to put the data into SPSS. So we'll go back to this Excel file and we'll select the top cell, top left cell, and then we'll go down to the bottom right cell. So we have a few hundred people in this study, and whilst holding shift I'm going to click on the bottom right cell to select all of the data. Then I'll go to Command or Control C to copy those data. I'll go back to SPSS, I'll select the top left cell, I'll press Command or Control V to paste those data in, and then we're almost ready to run the analysis. So one of the things we need to check with the Pearson correlation is that the data are normally distributed. So to do this, we'll go up to Analyze, then down to Descriptive Statistics, then over to Explore, and then we'll just transfer both of these variables over to this dependent list, and then we'll go to Plots. And I'm going to untick stem and leaf, but I'll tick histogram and I'll tick normality plots with tests. Then I'll go to continue and then to OK. And then I'm just going to scroll down slightly to this tests of normality table, and I'm going to focus on this Kolmogorov-Smolov side of the table because it's conventional, or there's a rule of thumb that you look at this test instead of this test if you have more than 50 participants, and you look at this side if you have less than 50 participants. And we have 290, so I'm going to focus on this side of the table. And what we want to see is that the values in the SIG column are above 0.05. So in this case, we can see that we have values below 0.05 in both of these rows. So the value is actually below 0.001. So that actually indicates that the data are not normally distributed. And if we take a look down here at this histogram, we can see that this sort of supports that, because what we want to see is a nice bell shape here, but we have a very sort of asymmetrical bell. And if we keep going down, so that was for cognitive function. If we keep going down a bit, we get the one for anxiety. And we can see here again, we don't have the classic sort of bell shape that we would like for a normal distribution. So normally I would suggest that if you see this, you would do a non-parametric equivalent of the Pearson correlation, such as the Spearman-Rowe correlation instead. But as this is just a tutorial, we'll just carry on and we'll ignore the fact that this normality assumption hasn't been met. A couple of other assumptions are that there is a linear relationship between the variables and that there is something called homoscedasticity. So I'm going to create a scatter plot to check both of these assumptions. So to do this, we'll go up to graphs and then down to scatter/dots. This simple scatter option is fine, so we can just go to define, and then we can transfer one of these variables to the y-axis and the other to the x-axis, and then we can go to OK. And that generates this scatter plot for us. If we double click on the chart, we can open this chart editor, and then we can go up here and it should say add fit line at total. So if we click on that, it puts this line of best fit through it. We can just close this and that will save automatically. So this isn't really what we want to see. What we would like to see is that we either have a band of dots going diagonally upwards, or we have a band of dots going diagonally downwards. What we have here is just like a horizontal band. So this doesn't suggest that there's a linear relationship between the two variables. However, these dots don't necessarily go against the assumption of homoscedasticity, which you can think of as having the data on the y-axis spread out to a similar extent across all levels of the x-axis. So here we can see that the data are spread out about this much on the left, and they are spread out a similar amount on the right. So what you don't want to see is that you have a sort of funnel shape, which would indicate a violation of the homoscedasticity assumption. So really this scatter plot suggests that there's not a linear relationship between the two variables, but it doesn't go against the assumption of homoscedasticity. But as this is just an example, we can ignore this and we'll just get on with running the analysis. So let's go up to Analyze and then down to Correlate, then over to Bivariate. And we can see that we have Pearson ticked as the default. So we can select both of these variables and we can transfer them over to this variables box, and then we can go to OK, and that runs the analysis for us. Let's take a look first at this Pearson correlation row where we have the Pearson correlation coefficient. And so we can see here that we have a very small number. So this number can range between -1 and +1. So here we can see it's very close to 0, and it is above 0. So it indicates that there's a positive relationship between the two variables. So as one goes up, so does the other. And we can see that that's kind of supported by this line going up very slightly in the graph. However, this is very close to 0, so it indicates that the relationship is very weak. And similarly, if we look at this sig two-tailed row, we can see that we have a p-value of 0.659, so this is way above 0.05, so we do not have a significant relationship between those two variables. So that's essentially how we interpret these results. Let's take a look now at how we can report them. So I have this example here, and I've started off just by referring to the results of that normality test that we did. So the Kolmogorov-Smirnov tests suggested that cognitive function and anxiety were not normally distributed. And then we have these stats. So let's take a look at where those come from. So we've got D equals 0.16. So if we go back to this output file, and if we go back towards the top and we're looking at this part of the test of normality table, and so cognitive function is here, and here's the D statistic 0.163. So I've just rounded that to 2 decimal places, so 0.16. Here we have the degrees of freedom, which is what we have here in brackets, and we have this p-value of less than 0.001, and that's what we have here. And then I've just reported the same statistics again for the anxiety variable. So those are what we have here. So next I've said that additionally, an inspection of a scatter plot, appendix A, so I'm just assuming that I would include that scatter plot as an appendix, suggested that there was not a linear relationship between these variables. However, the scatter plot did not suggest that the assumption of homoscedasticity was violated. And the next we get on to reporting the results of the Pearson correlation analysis itself. So it said that a Pearson's correlation analysis indicated that there was a very weak positive and non-significant correlation between cognitive function and anxiety. And then we have these stats here. So we've said that R equals 0.03. So that is coming from this correlations table, and that's this value here. So I've just rounded 0.026 to 2 decimal places. In brackets here, we have the degrees of freedom. So that's just the n value minus 2 in the case of a bivariate correlation. So 290 minus 2 is 288. And then we have the p-value of 0.659, and that's what we have here. So the last thing to look at is why I've described the correlation as very weak. So that's based on these criteria that Cohen put forward in 1988. He said that R values between 0.1 and 0.29, or minus 0.1 and minus 0.29, can be described as small. Those between 0.3 and 0.49 can be described as medium, and those between 0.5 and 1 can be described as large. So our value of 0.03 doesn't even meet the criteria for small, which is why I've described this as very weak. But we could also say it was very small. So that's essentially it for the Pearson correlation analysis on SPSS. If you have any questions, let me know and I'll try to get back to you. Thank you for watching, and I'll see you next time.